वेलकम यू ऑल। आज हम न्यूटन सेकंड लॉ को डिराइव करने वाले हैं। डिराइवेशन ऑफ न्यूटन सेकंड लॉ। मोस्ट इंपॉर्टेंट क्वेश्चन फॉर द बोर्ड एग्जाम। एक तो व्हाट इज न्यूटन सेकंड लॉ और दूसरा व्हाई दिस न्यूटन सेकंड लॉ इज ट्रीटेड एज द रियल लॉ। इसको हम रियल लॉ क्यों कहते हैं? Although there are three laws of motion, first law, second law, and third law, but why Newton's second law is treated as real law? तो जो first law और third law है that are derived from the second law. So हम पहले derivation करेंगे. Simply क्या लिखना है एग्जाम में? यहाँ पे हम I repeat it again many a times. I have already repeated it कि यहाँ पे हम कोई डिटेल इंटरप्रिटेशन नहीं देने वाले, सिर्फ हम एग्जाम में कितना लिख पा रहे हैं और एग्जाम में जो हमें क्वेश्चन बोला जा रहा है उसी के हिसाब से आपने आंसर देना है। तो यहाँ पे आप सिर्फ स्टेटमेंट लिखिए, द रेट ऑफ चेंज ऑफ मोमेंटम, द रेट ऑफ चेंज ऑफ मोमेंटम इज डायरेक्टली प्रोपोर्शनल टू applied force or external force, you can say. That is, if F is the external force, that is directly proportional to rate of change of momentum. This dp by dt is the rate of change of momentum, and you know well that momentum is the product of mass into velocity. You might have read in momentum that is a product of mass and velocity. And the change in momentum with respect to time called time rate of change of momentum. You can also write here the time rate of change of momentum is directly proportional to the applied force, that's external force. So इस proportionality को खत्म करने के लिए वो इंटर2 से कांस्टेंट से सपोज की, then we write dp by dt. And you know this momentum is mass into velocity, and if an object is moving, we treat here always mass constant. In mechanics we keep mass constant, so you have F is equal to K into d by dt of m into v. Since m is a constant, it cannot be differentiated, so you can write m this K into m d by dt of v. Now this d by dt of v is the rate of change of velocity gives acceleration. As you know, dv by dt is the rate, it's the time rate of change of velocity. The change in velocity is known as acceleration. You must remember this. When there is change in displacement, then there is velocity. When there is change in velocity, then there is acceleration. If velocity is not changing, that means the differentiation of velocity is zero. That means acceleration is zero. For constant velocity, acceleration is always zero. And if velocity is constant, differentiation of velocity is zero, means acceleration is zero. So here this dv by dt is acceleration. So you can write F is equal to K constant into ma. Treating K is equal to 1, you get F is equal to ma. This is Newton's second law. Or you can write it F is equal to m into dv by dt. This is in terms of change in velocity. F is equal to ma. This if I write the change in displacement is known as velocity and change in velocity is known as acceleration, then in terms of displacement I can write m into d2x by dt square. This is also the Newton's second law written in terms of displacement. The double derivative of displacement gives acceleration. Single differentiation of displacement, if the displacement x, you derivate it, you differentiate it dx by dt, it gives velocity. You again differentiate it d2x by dt square, it gives acceleration. So you can write F is equal to m into dv by dt, Newton's second law. F is equal to m dot d2x by dt square is Newton's second law. This is the Newton's second law. So F is equal to m into a. If m is equal to, now sticks units. if m is equal to 1 kg and a is equal to 1 meter per second square, then this f is equal to 1 kg meter per second square. 1 into 1 is 1. This f is equal to this kg meter per second square is known as Newton. Hence, the SI unit of force is Newton, and 1 Newton is the force when a body of mass m is equal to 1 kg is accelerated through an acceleration of 1 meter per second square. Or you can say the force F is said to be 1 Newton if it accelerates a body of mass 1 kg, if it moves a body of mass 1 kg with an acceleration 1 meter per second square. एक ऑब्जेक्ट जिसका मास 1 kg होगा उसको 1 मीटर पर सेकंड स्क्वायर की एक्सेलरेशन के हिसाब से एक्सेलरेट करने के लिए जितना फोर्स रिक्वायर्ड होगा, दैट फोर्स नोन एज 1 न्यूटन. सो 1 न्यूटन or Newton is the SI unit of force. This was the derivation of Newton's second law. You can write it like this: the time rate of change of momentum is directly proportional to the applied force, that is F directly proportional dp by dt. Then F is equal to dp by dt, where k is constant of proportionality, and we found and later that k is equal to 1. Then you can treat p is equal to ma, substitute here. Then you differentiate, since m is constant, it cannot be differentiated, it comes out. There is another way, is if m is variable, there is a chain rule, then there is another way. But for the derivation of Newton's second law, you have to confine it up to the results. So this is the way you can write in terms of change in velocity, in terms of change in displacement, how Newton's law can be written in different form. And this is how you calculate the unit of the Newton, unit of the force called Newton. Now, the second part mostly asked is why Newton's second law is treated as real law. Now, remember one thing here: Newton's second law is treated as a real law because it is the main mathematical model. It is a quantitative approach that helps us to understand the basic mechanics behind any object when the object is moving with some velocity or have some acceleration. So we have F is equal to m into a. Now, first example, why it is treated as a real law. How we deduce? Because real law, we can deduce also the first law and third law from this second law. So how first law can be deduced from the second law? यानी कि आप ये कह सकते हैं the actual law is Newton's second law and the first and third law can be taken or deduced from the second law. So if acceleration is equal to 0, if external force is 0, that's F is equal to 0, because when there is change in momentum, and change in momentum takes place due to applied force, due to external force. So when there is no external force, there is no change in momentum. So when F is 0, your MA is equal to 0. M cannot be equal to 0. This means A is equal to 0. When A is 0, there are two ways to understand A is equal to 0. A 0 के बराबर है, इसके दो meanings है. Either the object is moving with constant velocity or object has a zero velocity, or the object is at rest or object is moving with constant velocity. याद रखें, if the external force is 0, then there is no external force, there is no change in momentum. Momentum remains conserved. So I can write that in terms of that F is equal to ma. So I can ma is equal to 0. M cannot be equal to 0. That implies a is equal to 0. When a is 0, that means velocity is constant or velocity is 0. In both the cases, when velocity is 0 or velocity is constant, in both the cases you have acceleration 0. That is, you can write it like this: F is equal to m into dv by dt. F is equal to m into, if v is constant, say suppose then obviously change is equal to 0, dv by dt is equal to 0. So hence, you substitute here 0, you get F is equal to m into 0, so external force is 0. That means when external force is 0, either the object is moving with constant velocity, uniform velocity, or object is at rest. So object at rest or object moving with uniform velocity can give us acceleration 0. So acceleration 0 doesn't mean only that object is at rest. Acceleration equal to 0 also means that object is moving with constant velocity. This means if the object is moving with constant velocity, there is no external force to change its velocity. That is known as inertia. Simply, if the object is at rest, that means it remains at rest. No object, no external force can change its position. No object can increase or decrease its velocity. Its velocity is 0, object is at rest. It will remain at rest. Here, from this condition, the objective will remain in a motion. Here, in this condition, the objective will remain in a rest. But there is no external force. When there is no external force, an objective maintains its status, maintains its state of rest, or maintains its state of motion. This property or this maintenance of state of rest or state of motion is known as inertia, called the law of inertia. Is a Newton's first law, called the law of inertia, is known as Newton's first law, and this is the direction of from the second law. This first law is a qualitative approach, qualitative approach of Newton's law. And second law, this first law is qualitative, and second law is quantitative approach of Newton's law. Remember this thing, that Newton's second law is a quantitative approach that we treat, that we substitute, that we have a mathematical model, F is equal to ma, by virtue of which we can understand how much force is applied, how much of body is accelerated or decelerated. And first law is just a qualitative approach, means a body in a state of rest remains in a state of rest, and when a body it remains in a, if it's a state of motion, it will remain in a state of motion unless and until an external force is not applied. So this is the first law, and it is deduced from second law when the external force is 0 or when the object is moving with a constant velocity. Similarly, if a system, this is one of the examples that why Newton's law is a real law. The second example for why Newton's second law is real law is in third law. If it's a system with two particles, say suppose external force is 0 again, but this object applies the force on this object A, acts upon object B, and object B acts upon object A with the same force. The two bodies are applying force on each other, that is FAB gives a force FBA but in opposite direction. If A to B is a FAB force on object A due to body B, and FBA is a force on object B due to body A, then the two bodies are applying to each other. One is applying the force on body, another body B, another body B is applying the same force but in opposite direction. That is this FBA. Then you can write FAB plus FBA is equal to 0. Or you can say in other words, when external force is 0, this force is mutually, there's an equal and opposite direction, that is FAB plus FBA is equal to 0. There is no force. The total force inside the system remains constant. So you can write FAB is equal to minus times FBA. This means two bodies are applying दो bodies जो है वो force दे रहे हैं एक दूसरे को in opposite direction and with same magnitude. Here the two bodies are these applying force on one another with the same magnitude but in opposite direction. So FAB is equal to minus times FBA. That means to every action there is equal and opposite reaction. That gives us Newton's third law. This is Newton's third law. And Newton's third law stands for that to every action there is equal and opposite reaction. But within a system, there is no external force, but these two bodies are applying force on one another with the same magnitude but opposite in direction. Hence, the net force is equal to 0. There is no external force by virtue of which there is some change. So the net force in the system remains constant. This is another example of why Newton's second law is a real law. Now, one more important question, most important question now, centripetal acceleration. Now, we have another most important question as centripetal acceleration. Derivation for centripetal acceleration or centripetal force, you can otherwise say. Centripetal acceleration stands for the object, the acceleration seeking center, or the acceleration towards the center. Now we will draw a diagram, or then we use some geometry and we derive the centripetal acceleration. Let's consider this is an object moving in a circular path. The object, say at point P, is moving in a circular path with a uniform velocity v, and after some time it reaches another position Q, it reaches another point Q with the same speed v dash. Here the condition is this is uniform circular motion. Let us say uniform circular motion. An object at P is moving with a velocity v, and this velocity is tangentially here, and after some time reaches at point Q and another having a velocity v dash. One more point I say here, when you write velocity, it has two parts, a direction part and speed part. जब हम speed को direction देते हैं तो it becomes velocity. Speed is a magnitude part only, it's a scalar quantity, and velocity is a vector quantity. So velocity has a direction part and speed part. But I said uniform circular motion, and we know when velocity is constant, acceleration is 0. But in this case, it didn't work here. Here, speed is constant. Circular motion, the speed remains constant, but at every point there is change in direction. Change in direction. This change in direction causes the velocity change. That gives the acceleration. ये बहुत important point है, याद रखना. I said the velocity constant, acceleration is 0. But in circular motion, you can have speed constant, but the velocity is there, changing velocity is there, but changing velocity is due to the change in direction part. Because velocity has two components, direction part and speed part. This change in direction causes the change in velocity. That change in velocity gives the acceleration. So because at every point your velocity is tangential, changing the direction. Here velocity is this direction, 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 here velocity is this direction. Speed remains constant, but direction is changing everywhere. This change in direction produces acceleration. So let us consider the center O, and let the position vector from this center is R, and let the position vector from the center is R prime or R dash. You can write. Let's consider an object moving in a circular path or with a uniform circular motion. Let at point P, position vector is R and with a velocity v, and after some time it reaches at a point Q with a velocity v dash and having a position vector vr. Let me now calculate displacement vector. Displacement कैसे हम calculate करते हैं? If this object at this object reaches from A to B and followed this path, the displacement is the shortest distance. So here the displacement is this. Now this is a position vector 1, this is a position vector another. Suppose a P is Q. Suppose the displacement vector is this, because it moves from this to this, and this is displacement vector. Now using geometry, how can I write the displacement vector? Using vector law, this OP, this is P here, OP vector plus PQ vector is equal to OQ vector. This OQ vector, you right? You try a triangular law vectors. I said this is one of the position vector, this is another position, this is change in displacement, this. So you can write this vector plus this vector gives result in this. Using triangular law vectors, you know the triangular law vectors. First की tail, दूसरे के head से मिलेगा. So this is one vector, this is another vector, this is this. So I write OP plus PQ is equal to OQ. So OP is equal to R plus PQ is equal to, say, write a delta R change displacement, delta R, and OQ is equal to R dash. So your change in displacement is equal to R dash minus R. This is how you write this. I need here it. I will write it this here. Delta R will be equal to R dash minus R vector. This is change in displacement. Now, similarly, this is a vector. This vector is like this, and this is delta R here. So this is theta angle. It can be small theta. You can write delta theta also. Let me draw a line like this. From the center, we'll draw the line. मैं इस वेक्टर को, ये जो टेंजेंशियल वेक्टर v है, this is a tangential vector v, the tangential velocity, this is a velocity part. If I draw the parallel to this, like this, I draw the parallel. This is v then, and I will draw this. I will produce backwards this vector. It will go like this. It will be like then this. सिंपली इस वेक्टर को मैं यहां पैरेलल डाल देता हूं, ये पैरेलल वेक्टर इसका, और इस वेक्टर को मैं प्रोड्यूस कर रहा हूं बैकवर्ड. सो ये यहां पे ऐसे आ जाएगा, यानी कि ये दो वेक्टर जो है, एक को मैं यहां पैरेलल ऐसे डाल रहा हूं और इसको मैं बैकवर्ड प्रोड्यूस कर रहा हूं, तो ये एक जगह यहां से कट करेगा यहां पे, तो ये ऐसे वेक्टर बनेगा. ये v डैश होगा और ये एंगल थीटा. ये इस पॉइंट को अंडरस्टैंड करना बहुत जरूरी है. दिस इज वेक्टर v पैरेलल टू दिस, and this I produce it backwards like this, and I draw the ऐसा मैग्नीट्यूड बढ़ा दूंगा मैं पीछे डायरेक्शन में, तो यहां पे ऐसे आ जाएगा. दिस इज v डैश. Suppose this is o dash, and this is point R, and this is S. Then the change in velocity, this is v, this is v dash. Then the change in velocity will be, let's say, this, in this direction. यानी कि जो यहाँ पे चेंज इन डिस्प्लेसमेंट ऐसे था, यहाँ अब ये जो पोजीशन इन वेलोसिटी वेक्टर्स का जो वेक्टर फॉर्म आएगा, I will draw the vector in this direction, that is change in velocity. So I can again use this triangular law. Then I can write OR plus RS vector is equal to OS vector. That is OR is equal to V minus RS is delta V is equal to RS is equal to OS, that is V dash. So your change in velocity becomes equal to V dash minus V. Similarly, the way you get here, the change in velocity delta V is equal to V dash minus V. Or I can write simply, अगर मैं इसका सीधे ट्रायंगुलर लॉ इस्तेमाल करूं, एक को उल्टा करो. सपोज कंफ्यूजन की मैंने कैसे सीधे ये वेक्टर ड्रॉ किया डेल्टा चेंज, आप ऐसे भी लिख सकते हैं. दिस इज v and this is v dash, o r c s. You just take its reciprocal, becomes minus v. इसका नेगेटिव वेक्टर ले लो, इसका v dash, so you have a this vector, then this you get this, so you get v dash minus v is equal to this for the changing vector. ये भी आप ऐसे भी इस्तेमाल कर सकते हैं if you can remember this drawing the vector. Now here is the important point. You see, we know acceleration is equal to change in velocity divided by time, and in this case acceleration has the same direction जहां से velocity की direction होगी. The direction of acceleration is same as the direction of velocity, means acceleration and velocity are parallel. Since the change in velocity is also in this direction, that when you go ahead it will move towards center. So this change in velocity is center seeking. It is towards the center. That is why it is treated as centripetal, means towards the center. You see, the direction of change in velocity, and change in velocity is known as acceleration, and we know here the direction of velocity is same as the direction of acceleration. The change in direction is towards the center, so change in velocity is known as acceleration. So this acceleration is center seeking acceleration and known as centripetal acceleration, and is towards the center. So I can write acceleration a, this is how a is equal to dy by dt, and this is known as centripetal acceleration. Now how we solve this? This angle theta is same as this angle. This theta and this theta is same. You have here o dash, you have here o, and this velocity is making an angle 90 this with this radial part. As you know, in 10th class you might have read this theorem that tangent is perpendicular to the radius. It is same, this is tangential, it is perpendicular to this radial part, and this again tangent is perpendicular radial part. So by using the geometry, this theta will be equal to this theta. ये जो दो triangles है, these two triangles are similar. That means कौन कौन से triangle? OPQ and this ORS are similar triangles. Using similar law, you can write delta R by R. Sides are proportional, so you can take here this side divided by this side. Delta R by R is equal to delta V by V. Delta V by V. So you can write here delta V by V. Delta R by R is equal to delta V by V. So we can write delta V is equal to, V यहाँ आ जाएगा, यहाँ R है, into delta R. Dividing both sides by delta T, you can write delta T, you can write here delta T. Applying limit on both sides, you can write lambda delta T tends to 0 delta V, but delta T is equal to, this V is constant, speed is constant, R is constant, radius is constant, V by R. Limit only we applied here. Delta T tends to 0 delta R by delta T. So this is known as the rate of change of velocity, is known as acceleration. This is known as acceleration equal to V by R, and this is rate of change of displacement, is known as velocity. So A is equal to V square by R. This is expression for centripetal acceleration, and this is known as centripetal acceleration. You know, limit instantaneous form of velocity is instantaneous form of acceleration is instantaneous form of velocity. This rate of change of displacement per unit time is the rate of change of velocity per unit time. This gives acceleration, and it is the same direction towards the center, called center seeking or centripetal. This is a V by R, and this is a velocity V, and A is equal to V square by R. So multiplying both sides by M, so A C square is equal to M V square by R. This is called a centripetal force. FC is equal to mv square by R. So you can have, you might have read out the, put down this. So you can have AC is equal to V square by R multiplying by M. AC is equal to mv square by R. So this is called FC, means centripetal force is equal to mv square by R. You can have a question, derive the expression for the centripetal acceleration or centripetal force. This is the centripetal force. Also, V is equal to R omega. You can substitute here. V is equal to R omega. So F is equal to M into R square omega square divided by R. R cancel. So Fc is equal to M R omega square. This in terms of angular velocity. This is the only question if you are asked what is the centripetal acceleration or centripetal force. Can go up to Fc is equal to mv square by R. No need to go there. That changing B is equal to R omega. If you change, you can have other. You can have any times you can be asked in numerical where the angular velocity is introduced. So you can go ahead with some changes. But this is the exact expression. This is geometrical. You need to understand the geometry. Then you can find out the proof. Thank you very much.